Hello students, welcome. So uh, we will continue where we left off in the last class. We will continue with the projection of lines. In the last class we saw how we can project lines onto the two planes, that is the horizontal and the vertical planes, and we saw the different scenarios that may arise when we are talking about projection of lines, like scenarios of questions. First of all, the simplest one among lines will be that the lines will be uh, the line in question will be parallel to both the vertical and the horizontal plane. So, as in this case, as you can see, this line is parallel to the vertical plane and it is also parallel to the horizontal plane. And as you can see, if we are viewing from the front, it will be projected on towards the vertical plane, and if you are viewing from the top, this entire line will be projected onto the horizontal plane. And just like in the case of projection of points, what we are doing is we will just take the projection on the horizontal plane and the horizontal plane itself, and we will just rotate it in the clockwise direction by an angle of 90 degree. Okay, and if you are viewing it from the front, and this will be your orthographic projection. Okay, the orthographic projection for that particular line which was parallel to the vertical plane as well as the horizontal plane. So this will be the uh, front view, while this will be the top view. So that is how we take the measurements or the projections of a line that is parallel to both the vertical as well as the horizontal plane. Next, we saw in the last class, we saw the next condition or the next scenario of how a line is arranged. That is, the line will be parallel to one plane, while it will at the same time it will be perpendicular to another plane. So it can happen in two ways. As you can see in this case, let's say we are talking about this particular line. It is, as you can see, it is perpendicular to the vertical plane while it is parallel to the horizontal plane. Okay, in this case of this line, we have that the line is perpendicular to the horizontal plane while it is parallel to the vertical plane. So again, what we are trying to do is we will just try to project it towards the vertical as well as the horizontal plane. We view from the front. Okay, we view from the front, that is in this direction, and what we are getting is we will just, in the case of this particular line, what we are getting is just a single point. Okay, when we are viewing from the front, you can see just one point only, you cannot see that line. If you are viewing from the front, you can only see this point. But when we are looking from the top, what we are seeing is we can see the entire length of the line. Okay, so as in the previous case, we are projecting it, we looked from here and we projected that line onto the vertical plane, and we projected that line onto the horizontal plane by looking from the top. So this will be your top view in the horizontal plane, and this will be your front view in the vertical plane. Similarly, the second case in this particular situation, that is the line perpendicular to one plane and parallel to the other, this second line is perpendicular to the horizontal plane while it is parallel to the vertical plane. So we look from the front. In order to get the front view, what we are going to see is we are going to see the actual line with the true length, while when we are looking from the top, similar to the case before, we will just see a single point. Okay, this is that point when we are looking from the top. So again, we project it downwards. While looking from the top, we project it downwards to the horizontal plane and we get a point here. While looking from the front, we project that entire line onto the vertical plane. So again, in order to get the orthographic projection, what are we going to do? We'll just take the horizontal plane and take the projections and the projector, and we will just rotate it in the clockwise direction by an angle of 90 degree. Okay, so if you are looking from the front, then this is actually the orthographic projection of those two lines. This was the first line, orthographic projection of the first line. This is the front view. This is the top view. But for the second line, this is the front view and this will be the top view. That is one of the views will be a dot and the other will be the true length of the line, the actual length of the line. You can see it. So in this case, you see the actual length or the true length in the top view, whereas in this case you get the actual length or the true length in the front view. So you have to understand the difference. Then in the last class again, we also saw how we have the next situation of lines, that is the line in which it is parallel to one plane, whereas it is inclined to the other plane. It is not perpendicular, but it is inclined. Okay, so here also you have the two situations here. Let's take this particular line. This line is actually parallel to the horizontal plane, whereas it is inclined to the this is actually parallel to the horizontal plane and it is inclined to the vertical plane, whereas this particular line, it is inclined to the horizontal plane while it is parallel to the vertical plane. Okay, I hope the video is clear here in the 3D model. So I asked you to observe a particular thing that you could have seen already in the last class. Also we discussed this. We can see that in the case of such lines, the inclined lines, in one view you will get a reduced length and in the other view you get the actual length. Okay, so if you are talking about this particular line, the actual length of this line is actually, in this case in my model, it is 3.21 meter. Okay, so if I am viewing from the top, I will be able to get the true length of the line. I will be viewing the true length of the line because it is parallel to the horizontal plane. Okay, whereas if I view the same line from the front, what I am getting is a reduced length. As you can see here, I will be able to see only this reduced length. What is that reduced length? It is the dimension shown here, that is 2.24. So the actual length of the line or the true length of the line was 3.21, but because it is inclined to the vertical plane, the front view projection will be a reduced value. In this case it is 2.24. Okay, so you got to remember that in this particular case, when it is inclined to the vertical plane and parallel to the horizontal plane, in order to get the true length, you have to obviously view from the top, or the top view is the view which will give you the true length of the line. You can expect such questions. You can expect a question in which you are asked, you will be given some angles and locations of points, and you will be asked to draw the projections and also get the true length of the line. Okay, that is why this is important. So please do note this observation. So in the second case, again we have this particular line, and this line is parallel to vertical plane, whereas it is inclined to the horizontal plane. So what we are seeing is, if we are viewing from the front, we will be able to see the true length of the line, that is 4.69. In this case it is 4.69. The projection on towards the vertical plane, it is actually the true length, whereas if you are viewing from the top, you can see that you are getting a reduced length. In this case it is 2.66 meter. So the top view you are getting the reduced length, and in the front view you are getting the true length. So the inclination causes such sort of reduction in the projection lengths. Okay, so you have to keep that in mind when you are dealing with such questions. So we will just go back to a presentation slide then, because I have to discuss something with you. That is, Projections of lines, there are some terms that you should know. First is obviously the inclination of the line. It is nothing but the angle which the line makes with the reference plane. You already know that, right? From whatever we have seen already, you already know that. So this is kind of an example. We have already seen this in the 3D model also. You can see that this line AB, it is inclined to the horizontal plane and it is parallel to the vertical plane. Similarly in this case, so this angle of inclination, the angle it makes with the horizontal plane, it is known as the angle of inclination. In this case, the angle it makes with the vertical plane, it is known as the inclination or the true inclination with VP. In this case, it is the true inclination with horizontal plane. So now I will give you a new term here. You have to know the definition. You have to know what this is. It is the trace of a line. So basically what is trace? It is the point of meeting of the line with a reference plane. When this line, as you can see, the line is actually inclined to one of the planes, right? So if you are extending it, if you are projecting it in that direction itself, not in the perpendicular direction, but in the direction of the line itself, you will see that it will intersect with the with in one of those planes, and that is known as trace of a line. Okay, I'll show you the same thing in the SketchUp model. But let's before that, let's see the definitions. So there are two traces, that is a horizontal trace as well as the vertical trace. So the point of meeting of a line with the horizontal plane is known as horizontal trace. Okay, there is a line, it is actually inclined to the horizontal plane, and if it is extended, the point where that line meets with the horizontal plane, it is known as the horizontal trace. And in case of a line which is inclined to the vertical plane, the point of meeting of that line with the vertical plane is known as vertical trace. I'll show that in the SketchUp model here. So yeah, so see this particular line is actually inclined to the vertical plane. Okay, so if we are to extend this line so that it gets intersected with the vertical plane, let's see. Yeah, so this line has been extended. Okay, and see here, and it intersects the vertical plane at this point here. So you can see I have marked the intersection here with a point. Okay, this line which is inclined to the vertical plane, if extended, it is intersecting the vertical plane at a particular point. Okay, see this point here. Okay, the extension, so you can see it intersects the vertical plane at a particular point. This is actually the vertical trace. Okay, let's go back to the definition. The point of meeting of the line with the vertical plane is known as the vertical trace. So in this case, this is the vertical trace. Okay. Similarly, in the other case, in the case of this particular line, again, I'm going to extend it. Okay. When I extended it, it was intersecting the horizontal plane. So I'm going to mark the point at the point of intersection. So we have that here. Okay, so that is the point there. So this inclined line which is inclined to the horizontal plane, if extended, it will meet the horizontal plane at this particular point, and that is known as the horizontal trace. Let's go back to the definition. The point of meeting of a line with the horizontal plane is known as the horizontal trace. You can mark the horizontal trace as HT and vertical trace as VT. Okay, so that is basically the difference of horizontal trace and vertical trace. You have to remember this. And another thing to note is where you can see that particular trace in the corresponding opposite view. Okay, let me show that in SketchUp again. So we have this line here, we have this line and it is inclined to the horizontal plane and is extended, and it met the horizontal plane at this particular trace, and this is known as the horizontal trace. So if I am viewing from the top, okay, if I am viewing from the top, I can immediately see this point here, that is the vertical trace. Sorry, horizontal trace. Okay, this is the horizontal trace and it is properly seen in the top view. Okay, because if we are looking from the front view, we have a problem here. Why? Because it is coinciding with the XY line. As you can see, this intersection between the horizontal plane and the vertical plane, it is known as the XY line. And if you're looking from the front, we can see, in this case we can see that point, but when you are drawing in the paper, the thing is that point is actually coinciding with the XY line. So for the sake of understanding that, when we are viewing from the top, we will mark this as HT. This particular point we will be marking it as HT, and in the corresponding front view we will mark it as small h dash. Okay, and that will be our front view. Okay, just to clarify again, in the case of this line, this is the vertical trace, and vertical trace can be seen only in the front view. Okay, we are seeing this, we are looking from the front and see this point here. This is our front view of the line, and we can see the vertical trace at this particular point. Okay, and we will name it VT in the front view itself, capital V and capital T, VT. This is the vertical trace. Meanwhile, when we are looking from the top, again the problem is that it will coincide with the XY line. Okay, so here you will have to mark it as V. Okay, this will be the okay, in that case you will have to mark it as V in the XY line when you are drawing it. So I'll draw the entire projection now in sideboard. So keep this view in mind before we move on to how we draw this particular figure. Alright, so in this case I'll try to draw the orthographic projection of this particular line. Okay, so as with any case, the first step will be to draw the XY line. Okay, and we have that line which is inclined to the vertical plane, so we know that it will be, and it is in the first quadrant, so we know that the top view, it is the one which is actually giving us the true length. Okay, in the question you will be also be given an angle of inclination or the true length. Okay, in my case I am just assuming that I have the true length as well as the angle of inclination, okay, or the location of the first point. Okay, so just like that I will draw the true length in the top view. Okay, I'll draw the true length in the top view. This is the first quadrant, therefore top view will come below the XY line. Okay, this is the XY line. Okay, and now the next step will be to draw the projectors. So what will we do with the projectors? We just take it upwards. Again I'll take this upwards, then I'll draw the front view. Okay, for the sake of understanding I will just make it a little bit more thicker. This is our line. Alright, so in order for us to understand where you can see the actual vertical trace, when we are drawing this in orthographic projection, we will have to extend this line here. I'm extending this line and it meets the XY line at this particular point. Say at this particular point. So this will be the intersection that the line makes with the vertical plane, and you can, from the top, you will be able to see this as a point. Okay, now in order to draw the projection of the vertical trace, you just have to project from this line to this side and from this point towards the top. Okay, you just project it upwards and project from here sidewards. Okay, the point of intersection here will give you the location of the vertical trace. So I will name it. Let's say that this particular line is AB. This is AB. Okay, so if I am naming this, this is the top view, so the naming will be A, and this will be B. This is the front view, so A dash, this will be B dash, and this will be the vertical trace, because vertical trace is the point of intersection of the line inclined to the vertical plane, and it can be seen only in the front view. So in the front view, in the vertical plane, so when we are talking about vertical and horizontal plane, what is above XY line? It is the vertical plane. What is below the XY line? This is actually the horizontal plane. Okay, so VT can be actually only seen in the vertical plane. So therefore, in the front view, you will mark the VT, and here you will mark it as small v. This is how you draw the projections when you are asked to also draw the projection of the vertical trace. Just to see that in a three-dimensional figure, see this particular figure, the line inclined to vertical plane, it is making a vertical trace here, and this vertical trace, it is seen in the VP only through the front view, so we will mark it as capital V, capital T. Whereas the projection of that vertical trace on the horizontal plane, it will be just a point in the XY line, and we will name it as small v. There won't be any dash here because that is in the top view. This v is actually seen in the top view. Similarly, in the case of a line that is inclined to the horizontal plane, if the line is extended, it will meet the horizontal plane at horizontal trace, and this horizontal trace can be viewed on the HP only if we are viewing from the top, or when we are taking the top view. Here, this horizontal trace, the projection onto the vertical plane of the horizontal trace, it will coincide with the XY line here again, and because it is the front view, in that case we will mark it as H dash. Okay, so when we are drawing it, the problem is that we will have to take it in the reverse order. Okay, in such a case, first we will have to draw the front view. Why we have to take the front view? Because the true length of the line is available only in the front view. Okay, so we'll draw the true length with the given inclination, and after that we will try to take it to the XY line, and then we will find the H dash, and from there we will project it to find the point of horizontal trace. In this case, we will first take the top view, because only in the top view are we seeing the true length. Okay, and then we will project it to the XY line, and from there we get the V, and then we project it upwards onto the VP so as to get the vertical trace. It may sound confusing to you right now, but we will do some problems and you will probably understand how that happens. And this is not actually the first problem that you should have been doing, because the traces, horizontal trace or the vertical trace, happens in the case of a line which is perpendicular to one plane and parallel to the other plane. That is also possible, because trace will happen whenever there is an intersection of a line with a with a reference plane. Okay, so we will try to do some problems regarding the same. Just keep this in mind, and I was just giving you the vague idea of how what horizontal trace and vertical trace does, and what is the h dash in case of horizontal trace, and what is v the case of vertical trace. I mean the small v and the small h dash. Okay, so I think you were given this problem in the last class with Divya ma'am, and I guess you were given this question till this point only. Okay, you also have to mark its traces. Okay, let me repeat the question. It is a line AB, 40 millimeter long. It is parallel to HP and it is perpendicular to VP. The point A is nearer to VP and is 30 millimeter above HP and 20 millimeter in front of VP. Okay, so draw projections and also mark its traces. So immediately what we have here is that we have a line here. We have been given its true length, that is 40 millimeter. We have been told that it is parallel to HP and is perpendicular to VP. So obviously what trace are you going to get? You are going to get the vertical trace because it is going to intersect the vertical plane. Okay, you have also been given that the entire line is 30 millimeter above HP. They have told us that A is 30 millimeter above HP, but because it is a parallel line to HP, we have to assume, we have to know, deduce that the line is actually 30 millimeter above HP. Okay, and A is nearer to VP. Between A and B, the point A is actually the closer one to the vertical plane, and it is at a distance of 20 millimeter from the vertical plane. So with this information we have to start drawing it. So we have the line 30 millimeter above the horizontal plane, and it is the point A. It is somewhere around here. It is actually 20 millimeter in front of VP. Okay, and the total length of the line is actually 40 millimeter. So if I'm drawing the line, to keep one of the point here. Okay, if I'm drawing the line, it will be like this. This is the second point. This is the line that we have. So if I'm trying to measure this, in my case I'm using the unit meter. Instead of 40 meter, I will be using meter as 4 meter. Okay, that is my line, and this distance between the point A, this is A and this will be B. So it is, the point A is at a distance of 20 millimeter, or in my model it will be 2 my case it will be 2 meter. Okay, so this is our line, and we are tasked with the problem of drawing its projections as well as its traces. Okay, so how do we do projection? First we have to look from the front, then we have to look from the top. Okay, in such a case, select the line here. View from the top, we have the projection like that, and again we have the projection onto the vertical plane also. Alright, so this was the top view projection, this was the front view projection. So now obviously if you are asked about where is the vertical trace, in this case it is intersecting the vertical plane, so we only will have vertical trace, and this will be the vertical trace also. It coincides with the front view of the particular line. Okay, so let's see how we can manage that. So obviously, as with any other case, we have to rotate the horizontal plane along with the projections, okay, by an angle of 90 degrees. Okay, so this is actually our front view. This this is our front view in this case. Okay, so when we are talking about the vertical trace, we have the vertical trace here. So let us say if I'm asked to draw this in a piece of paper, how will I do it? You just do that in sideboard now. So again, your first step will be to draw the XY line. Okay. Mark it as X and Y. The first information that you have is that it is the true length of the line is actually 40 millimeter, and the line is AB, and the point A is actually at a distance of 20 millimeter from the vertical plane. Let's say that this is the point A. Okay, in the top view, if you have to know that distance from of the point A from the vertical plane, you can see that only in the top view. Okay, this is the top view, and then we know that it is perpendicular to the vertical plane. So, and the true length is 40 millimeter. So we draw a line 40 millimeter in length. So this is 20 millimeter, this is 40 millimeter, and mark it as P. This is A, this is P. And then how will I do it? We also know that it is 30 millimeter above HP. So how do I do that? I take the draw a projector upwards vertically, because we know that the top view and the front view of a particular point, it will always remain in the vertical line. Okay, so this line is actually 30 millimeter above HP. So what we have to do is we just have to measure from the XY line. We have to measure a distance of 30 millimeter. Let's say that this is the 30 millimeter, and we will mark that point here. Okay, we mark that point here. So what our point will be obtained here? We will get the front view of point B. So we have the B dash. We will get the front view of point A, because it is behind this point B dash. So in the bracket, after comma, you can mark it as A dash. We will also have the vertical trace behind A dash. So again, we will further mark this as the vertical trace also. We'll use a leader for that purpose, because they have separately asked for the trace. Okay, draw an arrow and just write BP. Another thing that we have here is that we can also mark, if we wish, we can also mark the top view of the vertical trace, that is small v here. So this is how we approach such a question. So I think that we were given two more questions in the last class, in which we are asked to draw the projections of lines which is perpendicular to one plane and it is parallel to the other plane. Try to draw the traces also in that particular question, okay, and see if you can understand it. Also keep in mind the case in which you are dealing with inclined lines. Okay, in the next class we will try to do some problems also in the case of drawing traces with respect to inclined lines. Okay. For now, let's keep this in mind, that is the horizontal trace as well as the vertical trace. What is horizontal trace? It is the intersection of an inclined line that is inclined to the horizontal plane. So you can see that in the horizontal plane when you are viewing from the top or when you are taking the top view. Okay, so horizontal trace will be visible in the top view, and whereas in the case of a line which is inclined to the vertical plane, it will intersect the vertical plane at vertical trace, and for to get that we have to view from the front. You have to mark the vertical trace here, and we will also have that vertical traces top view which will coincide with one of the point in the xy line, so we have to mark it. In this case it will also, the front view of ht will coincide with the xy line and we can mark it h dash. Okay. So keep that in mind. So when you are so the exercise that you have here, the other two questions you just add that you have to draw the traces also. So just make sure that you try to do it, and if you have any problems, we'll discuss that in the next class. Thank you.